Hey everybody, it's Sean. Today we're going to talk about how to run equations with our class values. So if you haven't seen how to do class values, see my previous video, regular expressions 2 videos ago, and then kind of the whole importing of ChemCAD files and data in my first video. Alright, so we have this this install dot map with more import requests. Okay, so now that we have all of our stuff together, we're actually going to put in or bring in some more properties so we can run new calculations. So instead of single properties, we're going to extract some coefficient properties. Coefficient properties are things like vapor pressure. So if you ever had a really mean professor for any material and energy balance class, or if maybe you remember some stuff from high school chemistry, you get these really long equations that have 5 or 6 coefficients that are all integrated to help you calculate the vapor or standard vapor pressure at temperature. Well, we're going to kind of I'm going to kind of show you how to do that. So I'm going to create this new dictionary. In this dictionary, I'm going to define all of the things that I want to grab. Excuse my poor typing. All the things I want to grab from this file. So if you remember, so this this is what our file looks like. Now if we scroll down far enough, we'll see these coefficient properties. So coefficient properties are things like liquid density, solid density, vapor pressure. This is the one we're actually going to care about. So we have these coefficient values, and then we have temperatures, min-max values, and we have an equation number. Alright, so we're going to jump back into this, and we're going to create our dictionary. This is our the abbreviation dictionary, really. No. I'm gonna pause the video, and you'll get all of the coefficient properties. But just so you know. Alright, I'm back with the rest of the list. So now that we have this list, we can now look through these component properties in our master file. So now that we have this master file, okay, we're gonna have to figure out a way to digest all this information, because the way that we've extracted our single properties isn't going to be the exact same as we're grabbing these. So the best way to do this is we're going to take a grab of this, and we're going to go back into regex 101. So now that we're back into regex 101, Control V, now we have a way to look at all this information. And now how we're going to start grabbing it. Okay, so the way that it always starts is that caret. We're always going to start with a caret. And then I'm going to do not a curly bracket. I'm going to do a parenthesis. You're going to look for words. Wrong space. So now we're looking for words. Excuse me. Okay, now we're looking for all the words in the group. Well, okay, what are we going for next? So we need to quantify it. Close it. Now we found all the words. Cool. Now once we find all these words, we are going to look for a space, because there's space in between the words and what we have. So now we have all the words and all the spaces combined. The important one's going to be this coefficients value. And then we're going to look for a new line, because this is all on several lines. And we're going to, we got to quantify it first. So now we're going to run all the way through the whole line after whatever it says, but gotta quantify it kind of lazily. And then we want words like equation, and we want to look at, or gotta quantify it, so it reads lazy quantifier of equations. Then we get coefs, so our coefficients at the bottom. And now we gotta look for something else. Okay, so what do we actually want out of all of this? Well, what we actually want out of all of this is this. So we're defining right now what we had, or what we're looking for. So right now what we're looking for is the numbers. Looking for all the numbers. There are several coefficient properties. There are looks like about 8 numbers there for every single one of them. So we need to grab them all. We want all the numbers and quantify it lazily. And that's all of our. That's how we grab all of the information, especially what we get for coefficients and equation number, because we really care about those. So yeah, here we're looking for our digits, decimal, and then the plus sign. So digit, decimal, or digit with a decimal, and then an E with a plus sign. Woo! Getting fancy here. Okay, so now that we've defined our regular expression, we're going to take our regular expression and we're going to go back to wrong button. Alright, now we're going to grab all of this and we're going to create a new coefficient properties path as we did our single props path. But with our recompile, we need to change something ever so slightly. So instead of looking at the re multi-line, we're going to go a re dot all, because we want all of it. We want all of it. Every single pattern object we can find in that bottom part of the. For this, we only want to look for these specific values. For everything else, we want it all. Okay, so now that we've had this class, we need to add a class for our coefficient properties. So for our coefficient properties, so just like our single value properties, we're going to have to create some stuff for them too. So to help ease along what we have, we're going to create another for loop. So after our properties, we're going to look for things in the key and value. So in our key value options, so a key, and then value. So our key values are the 2 positions in any given text or string. Sorry, typing what I was thinking. Sometimes the worst. Okay, so now that we have our extract, so now we have this key value, or the key value. Okay, what do we want to do with those key values? So for every value in properties, we want to make that a float value. So a float is how you make it into a number. We want numbers. We don't want strings. Can't calculate anything with strings. You get that if you're working in Excel and you try to do an expression or an equation on a string. It just tells you, is this it asks you if it's a name, because it doesn't know what to do with numbers. So Now that we have our key value, we're going to create we're going to create a set of strings for them. And those strings are going to be what we've defined above. So it's going to be a dictionary, and we want this coefs name pet find all at text and text text.text location. So we want everything. We want all the texts. All right. So now that we've created that for our single properties, now we have to do it again for our coefficient properties. So for key value, we need to in our extract underscore coefficient properties, we need on all the items in the coefficient properties, which is a little different than the way that we did the other. There's no indent, so I forgot something, which was that colon. So now we're going to create these coef values. So we're going to, or this is going to happen a little differently. So we want for coef in temp. If our coefficient value does not equal 0. So in Python, exclamation point equal sign means does not equal. So if it does not equal an empty set or empty string, then we want to append the value. So coef values dot append, which is a key or to key problem. So instead of going through and creating these dot maps for all of the values in the coefficient properties, we're actually going to do something a little differently. So instead of instead of pipping the dot map, we're going to take out dot map. I like to comment out the things I've used in the past, and now we're going to run something a little different. So instead of running dot map, we're going to run decay. So this comes from the collections library. We're going to import the decay function. And we're also going to import some other value or some other. We're going to import that the string library too. So now we have this. Got to run everything again. Extract single properties, extract coefficient properties, and then our class definitions. Okay. So now that we have our class definitions, create an empty value, but things will figure themselves out. Okay. So now that we're running decay instead, we can actually change how we're defining the extract coefficient property items. So instead of defining it like we did above with the dot map, we're going to do it with the decay function. So this for, we want coef values. We're going to name this coef values. And, well, what are coef values? We're going to create an open decay. So now that we have this open decay, we need to populate it with something. So, and we're also going to create temperature. Temperature is going to be somewhere in the coef name. Oh, it's not temperature, it's temporary. We want a temporary file for our coef's name strings before we give it something important. So we have this key value, but we're going to take it away from everything, so we're going to do a .l strip. .l strip, we're going to strip it away, and then we are going to split. and our split separator is just space. So empty set space. So what we just did is we created this temporary value for all these coefficients. And these coefficient name strings, well, part of those coefficient name strings, if you remember from our thing, is that they have these these really long values, and they're all separated by spaces. But if we want to get them and look at them individually, we're going to have to rip them apart. So we can actually look at, instead of it just being this really, really long number that doesn't look like a number anymore after you've taken it somewhere, we can look at each individual. So it becomes 5.2053 e to the 7th instead of just being the collection of numbers here. So we're going to go back to our file. So now that we have this temporary place, so for the coefficients in the temporary value, so if in that temporary value, if our coefficient is empty set, then we're going to create an append. So we want to put it in a list, or so if it's not equal to 0, we want to put it into a list. And that list is going to be a number, and that number should be represented as, or in the coef list, as some value in that set of numbers. So now that we're done with the if statement, we're going to create another for statement. So instead of our key value, we're going to define it as letter value, and then we're going to zip back up our string, which includes ASCII code. So ASCII number, ASCII is is how you code physical letters. So if you remember, the progression of code has gone from binary, so zeros and ones, to ASCII, which is your letters, and then there are some newer codes, especially to get to the emojis and the simple stuff besides the ASCII code. So we're lucky enough that it's included it's only in uppercase values. So we have our ASCII uppercase, and then we have our coef values, where we're taking everything. So so what are we doing for this for statement? For this for statement, we want to create a property value that is our value plus a letter. So that letter in the value, so if we wanted, so what are we really doing here? So for every coef, there's a position. This position is now going to be assigned a letter. So now if we wanted to say, I want coef A, we'll get that first value in the coefficient list instead of multiple values or the entire set of values. Granted, we also have the option of looking at each individual as well as the whole list. So if we put pvap, we're going to see the entire list of coefficients of pvap. So now we have our property letters of value, and now we're going to look, and we're going to dekey everything. I don't need a value error. I want a value. Okay, and now we're going to go back a couple indents, and we are going to dekey for all of our props dekey. Now that we've done all of these functions to them, we got to append it, and we're going to use it to append properties. Okay. Now that we've got all of this going for us, let's see if we can look at a value. So we want to look at maybe pvap, props.pvap a, props.pvap a. Let's see if we can look at it. Props is not defined. That's odd, because we did define it. Alright. Well, callouts are apparently not something I can remember. So props sit this. Okay. So apparently I don't remember how to call out any of the property values, which is a kind of how I'm supposed to be testing this. However, we'll just kind of power through and create the equation, and then I'll see if I can remember how to do any of this and maybe add an addendum to our current 4 videos. So now that we've created everything in our class, we're going to create the values and set some attributes so we can do calculations for it. So for everything in the key that exists right now, we are going to, especially for every value that exists, numblock is broken. We are going to so to get all of this, we're going to have, or to put all the values into an array, we're going to have to import numpy. Import numpy as np return. And for some of our other more challenging calculations, we're also going to include jaxnumpy as JNP. Jaxnumpy is the much more powerful version of numpy and includes a lot of the Jax library. The Jax library is being used. Oh, let's see. Here we go. The Jax library is being used for some super powerful information use and gathering at Google right now. If you've ever if you're curious, if we go to the Jax library, Jax library Python. So here's the actual library, so the commit Jax authors. Here's the real end version of it, and now that Jax is part of everything, it is an incredibly powerful library. You can kind of get into more information and understand exactly what they're doing when it comes to Google. So it looks very unassuming. Programmers are kind of those folks that try to make themselves a little more unassuming. But this is a lot more of what Jax can, there's kind of some of the stuff Jax can do. If you wanted to look at and see some of the stories with Google Jax, they're really interesting, but we don't really have time to go through those right now. So now we'll go back. We've created a numpy array, and we are going to put the num part into the array. So it'll be now the component. That component has a property, and for the component in the key in the props to key, we're going to do something kind of wild and crazy, and we're going to set attributes. I didn't mean to run that. For those values, we're going to set some attributes. Set attribute. Knew exactly what I wanted. And so we're going to set the self attribute, or we're going to set out attributes in the self, and then props and values. Okay. So now that now we can define and have all of our callable options right up front for us. And now to finish it all off, to create our create a function. We're going to define our pvap, define pvap as a function. So now I can take individual things from it. So pvap is now itself a function instead of its comprised of its individual components. And if you remember, we're going to go into here. So this is, or if you remember from our equation sheet slash our GitHub data as a text file. So we can see this equation number 101. So if you Google ChemCAD equation number 101, you end up with this document. And I use the Control F, find equation 101, it's right here. So that's y equals this exponential a plus b over t plus c natural log of t plus dt to the e. Okay, so now that we have this equation, we can take this information for every property and put it in here. So we've defined our pvap. Now time to create, and we want to return the function that we just expressed. So this Jax numpy exponential. We want pvap a, so our a value for any of the pvaps, plus. So this is b over t. This should be self of pvap b. This is b over t, or the b over t part of our equation 1.1, plus c times the natural log of temperature. It should be capital T. Capital T is temperature. Plus D times T to the E. T and raised to the E. Okay, now that we've got all that set out, we've created our function. Now we can run calculations with that function. You can find the pressure or vapor pressure for any of our imported components. Right now we only have 3 in there. So if you wanted to specify, oh, that's a typo right there. There's no 2 R's in power. Otherwise we won't have anything. Select over, general, check for spelling errors. Okay, so now that we have all of our components and our properties defined in a class, and then we've taken that class, we've stitched it all together, and now we've put it into an equation, we can now run calculations. So we can set t to anything that we want and create a value. So feel free to try this at home, as I remember to call all this stuff. Regardless, this is it's kind of how do you go through going from the individual property values from a ChemCAD file, which imports as a text, to defining these properties and then creating short versions of them to make dot map a little easier, and then forgetting dot map and doing the key, and then how to use regular expressions to go from a text file that has a bunch of different ways that it splits all the information up into individual values, and then taking those values, those keys and values, defining a class, and then putting it all together or stitching it all together so you create a usable equation that'll spit out some information, particularly to vapor pressure, for any of the 3 components that we just or that we've defined in the code. So that'll wrap it up for this set of videos. If you ever wanted, or if you want more information on how to do each individual step to this, check out the earlier videos. First video will teach you how to bring in this information, period. Second, we'll teach you how to use regular expressions in Regex 101 if you missed the refresher that we had today. 3 is how to create a class in general. We did that for our single properties, and then this one, if you don't remember, it's how to put together all of the coefficient properties, stitch it together, and make a big equation and solve it. Well, that's all I have today. I'll see you next time.